Okay, so far we talked about this sampling distribution mainly of mu, right? Talk about the interval estimation for mu. The another population parameter we're interested in is the population proportion p. Right? So for example, what percent of the population already have COVID? What percent of the population are homeowners, etc., etc. Okay, and so we have point estimates, which would just be a sample proportion, but more usefully or more useful, we would like to have an interval estimation as well. Now, everything that we've talked about with interval estimation of mu applies essentially basically to interval estimation for proportion, except that is even easier. So first, now, we need to check the sampling distribution if it's approximately normal. Okay, so what is the condition that will allow us to say that p bar is oh sorry, not p but p bar, right? P bar is distributed with a normal distribution. Now with mu we have two conditions, right? One is if the original population is normal, or secondly, if the sample size is greater than or equal to 30. Now, in this case, what we have is the condition is, well, here, let's call it the normality condition. Okay, the normality condition is n times p is greater than or equal to 5, right? And n times 1 minus p is greater than or equal to 5. So if both of these are true, and both of these have to be true, then we have a normality. Okay. Right now, for if the population proportion is unavailable, right? How do we know, right? Because which is most of the time, right? We simply use p bar to in place of p. So instead, we will have n times p bar greater than or equal to 5, and n times 1 minus p bar greater than or equal to 5. Okay, so we'll check that. That'll give us our normality. So if that condition holds, then p bar will have the following distribution. So first, if this holds, if this condition is true, then we are able to draw, okay, p bar has a normal distribution. Second, the expected value of p bar equals p, because p bar is an unbiased estimator. Right? It's unbiased estimator, so it's centered at p. And then what else? We need the standard deviation of p bar, or the standard error. The standard error of p bar, follow this formula. It's a square root of p bar times 1 minus p bar over n. Okay? All right. Now, so the interval estimate, right? Interval estimate formula is going to be very similar. Okay, so it's just going to be very similar. It's the p bar minus the margin of error time comma p bar plus the margin of error. Okay, and what is the margin of error? The margin of error equals the critical value. Now, with interval, oh sorry, with a population proportion, we always use z only. So always, so there's always use z critical value. Okay, so it's a critical value times the standard error of p bar. Okay, and that standard error p bar would just be that formula over there. Okay, all right, so let's give this a try. Okay, according to statistics reported on CNBC, 46 of the 200 vehicle samples were not covered by insurance. So, what is the point estimate of proportion of vehicles not covered by insurance? Clearly, there are more than 200 vehicles in the United States, so 200 is just a small sample, right? So our n is just equals 200. Okay, and of the 200, how many were not covered by insurance? Okay, so that will be x. X will be a 46. So then our key p bar, our point estimate, will simply be 46 divided by 200, or we're 0.23. Okay. I'll type that. Okay, now let's develop a 95% confidence interval. So we have our p bar, 0.23. We have our sample size is 200. Now 95% confidence, that means our alpha equals this. Right, 0.05. Then what is our critical value? Okay, 95% critical value. We already looked this up before, right? And we always use z, so we don't have to worry about if we know sigma or not, because there is no sigma. right? Which is the critical value, and so those would be 1.96. Right? 1.96, that's it. Okay, and now next thing we need is our standard error. P bar, so here we go. Okay, put that in the calculator. All right, and so our interval would be 0.23 minus the margin of error, and 0.23 plus the margin of error. So that will give us 0.2. Okay, so this is a 95% confidence interval for P, not P bar, P, right, for the true population proportion for P. Right, in another word, right, we can make, and there are many different ways we can describe our result here. So one way we can say is that we are 95% confident that this interval contains the true P proportion, right? The true population proportion. Okay, and that's it for interval estimation.